Video on Forces and Stresses in a Beam. In this video, you will learn about the behavior of a beam due to loading, as in the case of flexural bending, displacements, and internal forces. You will also learn about the coordinate axes, and the nomenclature, as used in the software. The loading in a beam occurs in the transverse direction, and the resulting bending is along the vertical z-axis. Because of this bending, the top fibers of the beam undergo compression, and the bottom fibers undergo tension. Thus, it is a flexural member. In the structural design of the beam, you will decide the appropriate beam material, which is usually concrete, or steel. Concrete, because of its durability, versatility, and fire and weather resistance. Chosen in major construction activities. Steel has a high strength-to-weight ratio, making it a better structural material. Nowadays, steel is often preferred for construction of high-rise buildings, long-span bridges, or buildings on soft ground, as it helps to speed up development, due to lesser workmanship compared to concrete, and also reduce on-site risks and minimize waste. Beams made of timber are also used in some situations. Timber is lightweight, easy to work with, and adaptable to off-site manufacturing, so it is often used in low-rise residential structures. However, timber can deteriorate over time, due to decay, mold, bacteria, insects, weather or fire. As mentioned before, the beam, being a flexural member, takes up both tension and compression. The reinforcement layout of the beam is being displayed. You can see the longitudinal reinforcement, the shear reinforcement, and a typical beam cross-section, showing the reinforcement layout diagram. To understand the nomenclature better, you need to know about the frame element axis, as per the software. The end of the member near to the origin is taken as the I-end. The next end, along the positive direction of x-axis, is named J-end, and so on. The axis along the horizontal x direction is called axis 1, along the vertical z direction is called axis 2, and the one along the horizontal y-axis is the axis 3. It is according to these axis numbers that the internal forces and moments are named in the software, which are axial force, P, shear force in 1-2 plane, V2, shear force in 1-3 plane, V3, axial torque about axis 1, T, bending moment in the 1-3 plane, M2, bending moment in the 1-2 plane, M3. These internal forces and moments are present at every cross-section, along the length of the frame element. For each load case and load combination, the frame element internal forces and moments are computed and reported at any point, at a distance measured from the I-end of the member. Please note, all the internal forces and moments mentioned here might not be generated in a single case, for a single member. This is a list of all the possible internal forces and moments that may be generated. For example, as mentioned before, shear V2 is a shear force in the 1-2 plane, meaning shear force on the plane between axis 1 and 2, that is, on the xz plane. Same is the case with moment M3, which is the moment in the 1-2 plane. In the next video, you will learn about design of a beam. Thanks for watching.